Hi, good morning Dr. Zairine and Dr. Noayu. I'm Henry and today I'm going to present on the methanol distillation column design as the major equipment. So we'll start off with obtaining all of the data from icon simulation software as seen over here, that we have our inlet, top product and our bottom product, and also the operating condition. And after this, we'll have a sequential steps to get our design of the distillation column. But for today, I will only focus on determining the number of stages, feed point location, and also column size due to a time constraint. So first, we will determine the number of stages and feed point location. There are two ways that we can do. One is using manual drawing and the other one is through software drawing. But for here, we will only use software drawing because it is easier. For manual drawing, we have to use a graph paper and we have to conduct the mass balance and draw the Q line, and also draw all the operating line for stripping and rectifying section to obtain our feed tray and also our number of stages. But on the other hand, if we use software drawing, it's actually easier than manual drawing because we don't have to draw it ourselves. We just have to enter all these parameters that are needed over here, such as reflux ratio, relative volatility, and so on, and we can get our number of stages and feed stage easily over here, as you can see. So the number of stages over here is 16 and feed stage is 6. And something to take note over here is that the number of stages here that obtained is actually the 100% efficiency, which after this we need to divide on the column efficiency to obtain the actual number of trays or stages. So moving on to the next one, the process design. The material of construction that we have selected is stainless steel, which it can prevent corrosion, and the column diameter calculated is 2.6 and the height is 13.28, which we have to validate that this ratio is correct by using the golden section rule. After validation, we prove that 5.1 is smaller than 20, which this ratio is feasible. And after this, we calculate the shell thickness, and the usage of the shell thickness is to get the outer diameter of the column, which this is the inner diameter that we have used, and 2.6 plus this one will be around 2.62 as our outer diameter. And as I have mentioned above, that the number of stages obtained here is 16, which is in the 100% efficiency, but we have to divide by the efficiency of our column or the process to obtain the number of stages, actual number of stages, which is 25 over here, and the feed tray or feed point over here obtained can be validated through the Crick-Bragg equation over here. Moving on to the next one, we have our mechanical drawing. So for the mechanical drawing, something important to be mentioned here is that over here you see that we have feed tray and 6 tray, and the feed point location is set over here. And this one, if you zoom in, is actually the hydrodynamics dimension over here. And this one is a hose distance between each one and another, and this one is a tray distance. So between the feed tray and the 6 tray is actually 0.45 meter, and 2.6 and 2.62 corresponds to the inner diameter and outer diameter respectively. And we have our remarks over here, which is obtained from the specification sheet as well. And from this specification sheet, something important to take note is that the type of tray that we use is sieve tray, and also the number of holes is around 10,000. And the insulation material that we have selected is mineral wool to insulate the heat inside. And after this, we calculate the distillation column costing, which we add up the empty distillation column cost and sieve tray cost, and we can get the total cost of our distillation column. And this total cost is actually the cost corresponds to 2007. Then we need to use the cost index ratio to get our final cost at 2019, because we can get only up until 2019 is because the CPCI index that we have is up until 2019. And something important to mention here is that this equation and this equation is given, and this Q corresponds to the weight of our empty decision column, and we can obtain this one by having this equation. We can obtain the empty decision column cost by having this equation, and the sieve tray cost by having this equation. And yeah, that's all for me, and thank you. Have a good day.